Hi everyone. So welcome to the fifth episode of our podcast. Here we have Anmol. It's an immense pleasure to have Anmol in this podcast who will talk about his machine learning applications in conventional well log. And also a good news about Anmol, he just got selected as a geoscientist in ExxonMobil. A little bit background about him. He is in fifth year, right? He
Yeah,
is in fifth year in applied geophysics from ISM Dhanbad. So without further ado, let's start talking a little bit about his research, and probably you can also share an experience how it went as an intern in ExxonMobil for our audience. And then,
sure.
as usual, since he is a machine learning enthusiast and he has applied machine learning to his research, so pick his brain on that. And finally, as usual, we'll try to end the podcast with some environmental topics and all. Okay, so let me share my screen and
Sure.
then we can talk
Thank
about
you.
Anmol's research.
Thanks, Tanisha, for my introduction. It is my pleasure to have here.
No problem. It's so nice to have young people, young professionals over here.
Yeah, thank you for the opportunity. Yeah,
No problem. Okay, so we see a comparison of predicted missing density logs from machine learning models and empirical relations.
yeah.
So how about you start? We see a workflow and all. Let's see how you start. Maybe I'll ask questions. Quite
Sure,
difficult,
sure.
but it's very interesting.
Yeah, so the idea behind this is like if we the measuring the well logs are is a really like expensive process in the oil and gas industry.
Mm-hmm.
So if we could predict some, and there is always a the data is not always available. So some of the logs are missing sometimes.
Of course.
So
Yeah.
the idea,
Mm-hmm.
so uh, we tried like if we could apply supervised learning machine learning approach to predict those missing logs and using a proper training with the well logs from the similar kind of lithology from the similar area,
Mm-hmm.
so we can predict those missing logs and save the logging cost.
Mm-hmm.
So so should I start with the explanation of workflow?
Yeah, sure. We do see regular machine learning workflow. So yeah,
Yeah.
let's start about that. Yeah.
So we have well logs from we have raw well logs from the field. So and then we do some from those well logs we do some pre-processing steps and exploratory data analysis
Mm-hmm.
in which we remove the outliers, we check the correlation between all the parameters, and we do some normalization steps as well, and like we are making the data ready for our to apply the to apply the training for the machine learning models.
Mm-hmm.
Then we also we also seen which logs can be used as the input parameters for predicting our target, which is the density. So which of the logs
Mm-hmm.
can be used, which are having the good correlation. We can see it from the we can observe it by using the correlation map.
Okay.
And
So
uh,
correlation between density log and what? The other log.
density other logs, yeah.
Okay,
So we
I see. Mm-hmm.
so we can prepare a correlation map from the we can prepare the correlation map and see the how
Mm-hmm.
the values are correlating.
Mm-hmm.
And after that and also we if we need to also check whether we have the wells which are mainly common. So we have the input parameters should be like common logs which almost all industries can acquire. So industries can use this approach if using those common logs.
Mm-hmm.
And then
So
we
by common logs, you mean like gamma ray,
gamma ray, yeah,
resistivity. Okay, I
yeah.
see. Mm-hmm.
The
Mm-hmm.
triple combo logs mainly that are
Mm-hmm.
mainly used
Right.
for hydrocarbon detection.
Mm-hmm.
So after that, we do the training and test. We select the training wells. How many wells? How many wells are needed for training our models, and how many wells we are going to predict. So in my research, I used around 20 to 25 wells. I don't remember the exact number.
Mm-hmm.
It was around between 20 to 25 as a training and predicted on two wells, predicted a density for two wells. And in the right hand side, it is mentioned what are the pre-processing steps which are applied. So
Mm-hmm.
we need to check the data statistics, how what is the variability. If there is some abnormal
Mm-hmm.
values, null values, we need to remove those.
Mm-hmm.
And also and also the we can also using the median filter we can also smoothen the logs,
Mm-hmm.
and we need to, but in that case we need to keep in mind if there is the small intervals or small beds or small changes are not missed, so we need
Mm.
to have to be careful in that.
Yeah.
And
Mm-hmm.
then after training and testing, we in this study we are trying to explain that the how the machine learning models are more useful and reliable approach than the empirical relation. As
Mm-hmm.
the empirical relation incorporated in this study is the Gardner's relation, which is
Uh-huh.
predicting the density from
Mm-hmm.
the compressional velocity. And uh, this Gardner relation and the empirical relation is not always reliable, not always good for all the types of lithologies in all the types of
Right.
formations.
If you have some
Yeah.
different like outliers or different
Yes.
lithology in between smaller. Yeah, yeah, right. Mm-hmm.
Yeah, exactly. So the Gardner relation is predicting very well in the lithologies towards
Mm-hmm.
shales. So that type of what can I say? That type of unreliability is always present in the empirical relations.
Mm-hmm.
So then what we try to do, we first try to go with the machine learning approach.
Mm-hmm.
In first we do the training, and using the after we know the how many wells to which of the wells to be trained,
Mm-hmm.
and after training we for applying the models we need certain parameters. So that parameters for optimizing those parameters we need to do the hyperparameter tuning.
Mm-hmm.
So in hyperparameter tuning, we supply a combination of those parameters, and it takes and it trains the our models with all the possible combinations and gives us the
Mm-hmm.
best parameters.
Best parameters, right?
Yeah.
Mm-hmm.
And then we use the those parameters for predict in the models, and then predicting the results from those. And then we have the predictions from Gardner's empirical relation, and then we compare, and the performance of the models was analyzed on the basis of the root mean squared error,
Mm-hmm.
and then and incorporating the geological knowledge. So in the so our test well is located in which near the group of training wells, or it is located farther from the training wells. So, and also the thing which I missed out is the we also do the normalization process, so
Mm-hmm.
which helps in the training the models more efficiently. So the expression the data was normalized with the help of this equation, which is in the right hand side.
Okay.
And so this was the overall
Mm-hmm.
workflow.
Uh-huh.
And so
And what type of model were you using? The deep learning
yes,
model?
yeah.
What?
So the we used three models. First is the based on the deep learning, which is artificial neural networks,
Hmm.
and then we use the gradient boosting regression
Hmm. Hmm.
and the random forest
Random
regression, which
forest.
are yes.
Okay.
So so if
And
we
that
move to
is
the
your
yeah
result over there, right? Okay, let me
yes,
go.
if we move to the next slide. So
Yeah.
in the top
Mm-hmm.
we have the just a diagrammatic representation of how the random forest model works. So there are a lot
So
of
this
decision
is
trees. Yeah,
which one is random forest?
in the left hand side. Uh,
Okay, this
in
one.
the yes, in the above slide, second slide.
Okay, I see. Mm-hmm. Oh, okay.
Yes.
Yeah, yeah, yeah.
Yeah.
Right. Mm-hmm. Okay.
So yes. So our output is the density. So
Hmm.
our so the random forest uses the n estimators parameters. So an estimated parameters came out after hyperparameter tuning. It came out to be 100. So we need around
Hmm.
100 decision trees to predict the densities. And so, and in the middle, we have the artificial neural networks, in which we have predicted, we have estimated the number of neurons,
Hmm.
uh, 300, 200, and 100 from the hyperparameter tunings, number of
Hmm.
hidden layers, and what is the activation function.
Yeah.
So after hyperparameter tuning, the results were in the right hand side in the bottom. So we used three hidden layers, and batch size was 60 epochs that we calculated
60
from
epochs, and what
hyperparameter
was your
tuning.
batch size? What was the batch size?
Batch size 60.
60. Okay, I
Yeah,
see.
in the we can see in the right hand side in the bottom
Oh,
table.
right, right. Batch size. Oh,
Yeah,
okay, and epoch was 1500. Okay, I see.
yeah.
And
So
rectilinear RLU. Okay, got
yeah,
it. Value. Yeah.
so these are calculated based on the hyperparameter tuning. We tried different
Okay.
possible uh,
Mm-hmm.
parameters, and then we got these
Hmm.
optimized parameters for ANN.
Hmm.
and and like after the we have calculated, we for both the wells, the all the three models were giving the decent predictions, whether it
Hmm.
is on the interfaces, whether it and the interesting thing is there is also oil bearing formations in these for in these data set in these well logs. So it is from the North Sea Utsira High region, the
Hmm.
data, and there were some oil bearing intervals were also present. So
Hmm.
in those intervals also the predictions were good, and
Hmm.
even in the interfaces also. And the we can see from this visually, we can see it from here.
Hmm.
This is for the in the left hand side, it is for well 1, which is 34 3A, and on the
Yeah.
right hand side it is for 25 10 10.
Hmm.
So
Okay. Two wells.
so
Mm-hmm. Right.
yeah, so the predictions are like good, and they are following the trend. And we can see the predictions from the Gardner's equations are not very as reliable as when we can see the actual is black in color and the Gardner is in red color.
Hmm.
So
Over here.
the
Yeah. Mm-hmm.
yes, yes.
Right.
And the left hand side, we can also in the very left hand side, in the like for the 34, yeah. So we can see that
Mm-hmm.
it is not following even the trend also.
Yeah.
So
The
so
black
that
one is Gardner. No, sorry, the red one is Gardner, right? Yeah.
yes,
Okay.
yes.
Yeah, you're right. Yeah, you're right. Mm-hmm.
So these were the results. And for both the wells, as we can observe from the RMSE scores, the artificial neural network emerged as the best predicting model for the well 25
Mm-hmm.
10 10, and for the well 34 33A, the gradient boosting regression emerged as the best predicting model. So based on the RMSE. And
RMSE
if
score,
we
right.
yeah,
Mm-hmm.
and if we add the RMSEs, and if we add the RMSEs, then we observe that the gradient boosting model was giving overall the least RMSE. So for this study, uh, it came out to be the most suitable model. Uh,
However, I do think if you just improve the neural network, then also this can
yeah,
be, yeah. So,
yeah, like yeah,
yeah,
we estimated that, but we did this study on in the lockdown period only. We have the access to our laptops only. The processing power was not very good,
yeah,
so
right. So
that's why.
you didn't use Colab, right? Or are you using Colab now?
Yeah, we used in Collab and all. Yeah, we do use Collab,
Okay,
but
I see. Mm-hmm.
yeah,
But that was your limitation.
yeah,
Yeah,
limitations were
yeah,
there.
definitely. There is so much scope for this improvement. Very interesting study, Anmol.
Yeah,
So maybe we can now, it's very helpful. We can now go back and start talking a little bit about your journey as a geophysicist, um, how you actually, how was your experience as an intern in ExxonMobil and then the switch? Because we did talk a lot about deep learning, and of course,
yeah,
deep learning is definitely helping here that we can already we already saw that. But maybe let's talk about how your transition is happening.
Yeah. So, my like do you want to know about the reason behind the transition or
No,
uh,
as a whole, because you are on fifth year, so and then you'll be transitioning to ExxonMobil. So, and how did you feel about the academic environment versus the like the in your internship? Maybe just a gist for our audience. Yeah.
yeah, the experience at ExxonMobil was really amazing. I got an exposure about oil and gas industry, how the oil and gas, what are the various phases of oil and gas field development, and how we are
Mm-hmm.
producing the oil. And I met a lot of new people and enhanced my networking. I enhanced my soft skills, technical skills, and my project involved a lot of different integration from different disciplines, so it was a
Mm-hmm.
collaborative teamwork approach, and I enjoyed the challenges that came and how I reached to my final deliverables. So overall it was a very nice experience at Exxon. And
Hope your new role as geoscientist will be that challenging, right?
yeah, yeah,
Yeah.
yeah, the geoscientist roles are always like the finding the hydrocarbon and such a huge data and a huge amount of data and huge amount
Right.
of huge vast area. It's really challenging,
Yeah.
and
Yeah.
there are a lot of uncertainty and heterogeneity is involved in, always is present.
Yeah.
So
So much. Yeah. And hopefully you'll just bring all your machine learning applications over
sure,
there too.
sure, sure.
Great.
I
Great.
will love to integrate
Yeah. We need
these
to have a
reliability.
follow-up
Yeah,
podcast when you develop those algorithms, right?
sure, sure, sure. I will love to give that. Yeah.
Yeah. And so maybe finally, let's talk about the environment. So the conventional energy and clean tech, right? What's your opinion? Because of course, you are joining a conventional energy company, and what's the correlation, or how do you see things there? Yeah.
So I have seen like that there is a lot of efforts being put on in the CCS mainly,
Carbon
so that we
capture,
can,
carbon
yeah,
sequestering, right?
yes.
Uh-huh.
So by the big oil and gas companies, they are like they are focusing more on CCS, and the more investment is also coming in those. The more partnerships are coming, and also so it's a through CCS we can achieve the net zero.
Hmm.
Uh, yeah, so net
Right.
zero, and also like I feel that it has both positive and negative implications on oil and gas industries. Like positive, we have the if we integrate the CCS, we have the emission reduction, we have the
Right.
images, or public image of the company will also gets better.
Yeah.
And negative impacts, I could think like CCS may enable oil and gas company to continue their reliability on fossil fuels instead of transitioning to cleaner energy, renewable energy
Renewable
sources.
energy. Yeah.
Yeah. So, and also CCS might also divert funds and attention from other sustainable energy solutions.
Hmm.
So I think these are some negative impacts also.
Mm-hmm.
But
Yeah.
I yeah, that's all I saw. And also there is a like more focus is given on machine learning, uh, machine implementing the machine learning algorithms to
Algorithms too. Yeah.
make
That
the
will
work faster.
actually, yeah, kind of even like machine learning algorithms are mostly used for reduce the time, right? Scalability and all. But I think that these algorithms would be a very big, like in future, they will play a very big role in the reducing the carbon emission actually.
Yeah,
So yeah, so I hope that you work on these domains, and then we also bring you back,
yeah.
and we'll discuss about that. Well, Anmol, do you want to add anything else about environment and all? Are your final words or any final concluding sentence?
Uh, yeah, we are like seeing the impact of climate change on our daily life. We can see uncertainties in the weather, uh, uncertain rainfalls and fires. So
Right.
uh, floods across the many cities. So we need to be serious about it, and we need to focus more on the uh, we need to we need to shift our focus from, I mean, and not only from the uh, industry, as well as we also from our individual efforts. We need
Hmm.
to reduce the carbon emissions. And not, so I was trying to say that not only the government but also the people also should also try to from
Hmm.
their individual efforts to try to reduce the carbon emissions,
Hmm.
and focus on using the conventional energy resources less, and emitting the less carbon emissions,
Carbon
and
goals, yeah.
yeah,
Or
and
yeah,
using the
or
renewable
that come in the
sources.
between, right? Mm-hmm.
Yeah,
Yeah. Find a balance, right? Kind of
yeah,
between
kind
the
of
kind of,
balance
yes,
to
yes.
achieve the net zero. Yeah,
To achieve net zero, yeah, I also believe it's not like you cannot shut down conventional energy completely.
yeah,
It
that's
is
true.
not, yeah, not
And
possible.
that's all the major oil companies, oil and gas companies believe also, like
Yeah,
the conventional cannot be shut down like more rapidly. The dependency will be still there,
yeah.
but the thing which we can do is to maintain a balance, maintain a net zero, reaching
Mm,
the net zero basically.
yeah.
Yeah,
Great, great. Thanks for your insights, Anmol, on clean
yeah,
energy net zero. So I think with this, we will end the podcast, and you'll be posting this on YouTube, and stay tuned
sure,
for
sure.
our next episodes. Okay?
Yeah, sure. Thank you so much, Tanishta.
No problem.